Hello and welcome everyone. Welcome to the day 20 of our code camp. I hope I'm clearly audible as well as visible. So if I'm clearly audible, just write down yes in the chat box. Hi Sahil, hi, hello. How are you? So how is your practice going on, everyone? Okay, thank you for the confirmation. Hi Manjunath, hi. Okay. So have you been following this entire series or is this your first session? Who of like how many of you are attending the session for the first time? Going good, but getting stuck after tree data structure. Okay, so after tree, which data structure are you studying? Okay, first, okay, so it's the first session for a learner. So I would like to tell you about the previous session as well. So you can follow this entire series at your own pace as well. You can note down the videos of playlist and simultaneously you can start whenever you want the 21 days of continuous DSA practice, right? How to practice DSA for a fresher. So we have a question from Manjunath. He says, how to practice DSA for a fresher to coding. Okay, so if you are a fresher, no, the path is same for everyone. It does not matter if you want to, like let's say, follow the path of interview or follow the path of, like let's say, computer programming. So the path starts from learning a language. Okay, so directly you can't jump to data structures before knowing all having a practice of any language, right? So first of all, learn a programming language, and then you can follow the basic questions. You can start DSA, basic DSA, and practice DSA standard questions, and simultaneously keep on continuously practicing each and every day, right? So because consistency will help you to increase your thought process. Can open BCA student get a job in product based company? So you can write down the qualifications of the candidate and they will it will be mentioned if BCA students can apply or not. Okay, so like understood the topic but not able to solve medium level questions. So if you are facing difficulty in medium level questions, make sure first of all you have like already studied all the, let's say, standard problems very nicely, or else revise the standard problems and then come back to solving medium questions. Okay, so basically, Sahil, if you are just saying that you have just started the medium questions and then you are facing this difficulty, then that's totally okay, because as you have just started, no, so it will take time for you to develop your thinking process according to that data structure. It will take some time in beginning. Okay, so maintain consistency. So without any delay, let's start today's session. And so in today's session, I'll be discussing various like different techniques. Apart from data structures, we have different techniques which can be helpful to us and solve different questions, right? So I'll be discussing a very famous technique which is asked in interviews, and the questions can be very much like you can see then there can be an advanced question from this topic as well, and then there can be a very easy question as well. Okay, so vast variety of uh, difficulty level is covered by this question. Okay, so let's start. So first of all, uh, let me share the screen. Okay, I hope my screen is perfectly visible. Right, so without any delay, let's start. So how many of you are aware about, let's say, apart from basic, how many of you know about two pointers approach? Have you heard about two pointers approach till now? Were you guys, while solving questions of, let's say, arrays, you might have heard about the technique two pointers approach. How many of you have heard about two pointers approach? A plus, yeah, write down yes in the chat box if you have heard about. Okay, thank you. So yes, two pointers, sliding window, yes, exactly. Pratik and Sahil, yes. So basically, two pointers approach. Let me explain you what is this approach. Okay, so let me give you a small question. This is a very famous question. Let's say you are given an array which is already sorted. Okay, you are given a sorted array that contains, let's say, n number of elements in it, and over here n is equal to 6. Now you are given a some variable that says sum is equal to, let's say, 24. Okay, so you have to find out that, find a pair inside this array that sums up to 24. Okay, basically you have to find out two elements a and b whose sum is equivalent to 24. Print those elements. So what can be the approach of finding a and b? Can anyone from the audience reply in the chat box? What can be the approach of finding a and b? Find a and b. What can I do in order to find two variables from this array, two integers from this array that will have sum equivalent to 24? A basic brute force approach can be, I can find all the pairs a comma b. I can try out each and every pair from this entire array, right? And that approach will take around order of n square amount of time, because you will be finding each and every pair. First this pair, then this, and this, and you will be starting this in this manner, and you will be checking if any of the pair is giving you some 24 or not, right? And eventually, what will be the time complexity of that approach? So it will be something, let's say, for the first index it will be having n minus 1 number of elements. I mean n minus number of 1 number of pairs. This many elements can make pair with 1. This will be having n minus 2 number, this will be having n minus 3, and at the end 1, and at the end 0 will be there, right? Because for the last element you cannot make pair because nothing is there on the right hand side. Okay, Sahil says at current pointer find the difference available in the hash map. Okay, okay, Sahil, got it. That can be the approach, right? Find the difference available in the hash map. Okay, so what kind of details are we going to store in the hash map? Find the difference available. What will be there inside your hash map? So 5 at the last index will be getting 0. So overall you can say n minus 1 into n minus 2 into n minus 3 and so on into 0. Last 0 will not be taken, or else you will be having all the values equivalent to, okay, hash set will do. Okay, so now over here this brute force approach is going to take too much amount of time, as you will be checking each and every pair, right? I don't want to do that. What is the other thing which I can do? So everyone from the audience is saying that we can use a hash set. Okay, so what kind of data do I need to set inside the hash map? So basically we know that a plus b. So basically we know that a plus b is equal to 24, right? And we know that a plus b is equal to 24. So now over here what I can do, we know that a can be found by just, if I know the value of b, then I can get the value of a. Exactly. So what I'll be doing, in order to find the value of a, now from this I want to know what details should I store inside my hash set or hash map, whatever you are using. So this is a hint. What is the other thing I can do apart from this? Like if A is equal to 24 minus B, now I want to iterate over this entire, let's say, array. What should I store inside the hash map or hash set? What do you think should I store inside the hash map? Okay, the visited value in a list. Okay, so basically everyone is saying that I will be storing the visited value. So let's start and see what is it correct or not. Okay, so first of all, this is the first element and it is not visited. So basically, what I'll be doing, 24 minus 1 is equivalent to 23, right? So currently I'll be storing the element 1 inside my hash map, right? So now moving on forward, and now I have, let's say, A is equal to 24, the value of B is equivalent to 3. So 24 minus 3 is equal to 21. Do you see inside the hash map, do I have 21 or not? No, I cannot see 21 present. So basically now I'll be storing the value of 3. Basically I'll be storing the value of 3, and now let's say 24 minus 5 will be giving you 19, and A is equal to 19, so I'll be storing 19 inside my hash map. Okay, and let's say A is equal to 24, and now 24 minus 19 will be giving you, and over here instead of 19 I have to store the element, not the difference. Okay, so 5 will be stored, and now over here on reaching this element, 24 minus 19 will give you 5. So A, was this value 5 encountered before or not? I can see yes, 5 was encountered, so that means the other element is 5 and the current element is 19, and the sum of this 19 and 5 will give you 24. So this is how I can find the uh, two elements that add up to 24. So now what will be the time complexity of this approach? An entire iteration is required. Let's say in worst case, I will not get any kind of answer. And what will be the space complexity in this approach? The space complexity will be order of n, because let's say there was no answer possible and you stored each and every array element inside your hash map. So this is going to be my time and space complexity, right? Yes, exactly. Yes, I. So can I do better than this? Now here comes the two pointer approach into picture. Can I do better than this? Yes, you can do better than this. So you'll be asking which part? At least the time complexity cannot be reduced than order of n. I agree with you. What about this space complexity? So I said that the array given to you is a sorted array, right? And you can observe over here as well. This array is going to be sorted array. So why not utilize the arrangement, right, which is given to us? First approach can be improved with binary search. Okay. Okay. So basically, so now I want to use something better than that. So what I'll be doing, as the array is already sorted, someone suggested I can use binary search. Already we know about binary search. I wanted to explain a new technique which can be useful to you. Okay, the technique is similar to like searching an element inside the array, but over here you will be able to search two different elements. Or let's say with combination of this approach, you can find three different elements as well, right? So the two pointer approach can be utilized over here. So how will this approach work, two pointer approach? So basically now I have taken the same example and let's erase it. Let's make it little bit clear, right? So sum is equal to 24. Now let's say I have mentioned that the approach says two pointers. So some pointers needs to be done, right? So there will be one pointer left and there is one pointer right. So now what I'll be doing, I'll be getting two elements at the left index and at the right index, right? So basically array of L and array of R. And obviously, as the array is already sorted, we know that array of L will be lesser than or equal to array of R all the time. This condition will hold true, right? Because R will be pointing to a larger element always. So now what is the sum of array of L and array of R? So let's see over here, it is 1 plus 30 is equivalent to 31. Now what is our target? The target sum is equivalent to 24. I need the elements that add up to 24. So what is the inequality between the sum which you have, and what is the inequality between the key which you have? So 31 is greater than 24. So now actually if I somehow decrease the value of 31 and try to find such element that add up to a value lesser than 31, then it is possible that I will be able to find some equivalent to 24. So basically what I'll be doing, I'll be decreasing the value of r. Decreasing the value means not subtracting anything. Decreasing the value means changing the position of r. That means you are trying to look for an element which is lesser than the value pointed by r, which is lesser than 30. So it will be present on the left hand side, so I have moved the r pointer. So basically whenever you find this kind of condition, array of l plus array of r, that is the sum which you have currently, that sum is greater than key, then that means I need to decrease the sum. If this is the condition, then that means I need to decrease the sum. So what I'll be doing, I'll be moving my r pointer towards the left direction. Okay, so this is the thing. Now moving on forward, now my position of r is over here. Let's find the sum again. So 21 plus, I mean 22 plus 20, this is 1. 1 plus 22 will give you 23. Now what is the inequality between 23 and 24? 23 is lesser than 24. One more condition has been encountered. Array of L plus array of R. This sum is lesser than the key sum. So that means I need to somehow increase the value of the sum. I need to increase the value of this sum. So basically the R pointer always move in leftward direction, and the pointer left will always move in this direction, in the rightwards direction. So I want to increase this sum. I want to increase this sum. So now if I move this R pointer in the leftwards direction, that means if I move the R pointer in the leftwards direction, so it will be pointing to 19. That means a value lesser than 22 has been encountered. So if I decrease any of the value in the sum, then obviously the sum will be lesser than 23. But I don't want to do that. So let's see, instead of moving the R pointer, what if I move the L pointer? So that means moving the value of L pointer. So that means I have encountered 3, and now this 1 can be replaced by 3. No, the array must be sorted. Okay, over here the array must be sorted for this approach, for two pointer approach. So now I have increased or moved, I have moved the L pointer towards the right hand direction, right? And now the value of 1 can be replaced by 3. So that means the sum will obviously be increased, right? Because I have replaced a smaller value with a larger value. So now the sum will be 3 plus 22, that is going to be 25. Now what is the inequality between 24 and 25? So basically over here for this condition, array of L plus array of R, if that sum is lesser than key, then what? I need to move the L pointer towards the right hand direction. There was a restriction that L pointer can move towards this direction only, and the R pointer can move always towards this direction. Due to this restriction, this inequality. So if you remember this, let's say constraint regarding pointers, then every time you don't need to think about this approach. Every time you don't need to you don't need to memorize this condition, that when to increase and when to decrease the value of R and L. Okay, so just uh, understand and keep this in mind for the two pointer approach. And now the other thing possible can be array of L plus array of R can be equivalent to key. This can be the possibility. So in that case, you have simply have to print the value of the element at array of L, and you have to print the value of the element at array of R. So they will be printed. There are the elements that will be having some equivalent to key. So now let's quickly, with the help of this algorithm. Yes, this is not suitable. I mean, this is not the approach for sorted arrays. As I already mentioned, the array will needs to be in sorted manner. Okay. Every time the array needs to be in sorted manner, mark my point. Without the array being in sorted manner, this approach cannot be used. Okay, so this is the approach, and let's try to find the elements. Okay, so now 3 plus 22 will give you 25, and 25 is greater than 24. So I need to decrease this value. Decreasing this value means I need to move the r pointer towards the left direction. So r will be over here. And now what will be the sum? Let's see. The sum will be equivalent to 3 plus 19, that is equivalent to 22. And 22 is less than 24. I need to increase this sum, so move the L pointer towards the right hand direction. So moving over here, and now what will be the sum? 19 plus 5 will be equivalent to 24. This is 5 plus 19 is equivalent to 24, and we have found our two star elements, 5 and 19, and they can be printed in the output. So is this part clear how this two pointer approach works? This is the algorithm. And when should you stop? If this I and J, let's say if this L and R, they cross their path, then that means you have not found the sum, right? You have not found the sum. That means you simply stop the iteration whenever the value of L and R cross each other. Is it clear? Write down yes in the chat box if this part was clear to everyone. Okay, thank you, Milan. Share an example of two pointer for unsorted array. Two pointer approach cannot be applied on an unsorted array. Okay. So this is the two pointer approach, and actually we have solved a question. Uh, this is one of the standard question which is a part of an array, which comes under array topic. Okay, so this is the approach. Now we have studied an approach to find two elements that add up to a targeted sum. Now here is our first question of this session, and I'll be sharing the link of this question. So the name of this question is find triplets with sum 0. Okay, I'll be sharing the link in the chat box, and I'll be giving you 2 to 3 minutes so that you can read down the problem statement. And those of you who have like read the problem statement, just write down yes in the chat box. Okay, try to read the problem statement, try to understand what the question is trying to say. Read out the examples, example 1 and example 2. I don't think the question is difficult to understand because it is somewhat similar to what we just saw right now. Okay, so Pratik has already read the problem statement. That's really fast, Pratik. Okay, so let's. So now I have. Okay, so now let's try to understand the problem statement. Okay, so this is a very easy kind of question, but this question helps you to utilize the two pointer approach in a different manner. Okay, Arushi also read the problem statement and Pratik as well. Good. So let's read the problem statement. Given an array of n integers, check whether it contains a triplet that sums up to 0. Okay, Milan. Okay. So we have to find three elements or a triplet that contains three elements, which is having some equivalent to 0. And there is something written in note that is return 1 if there is at least one triplet following the condition, else return 1. If the answer is possible, then return 1, else 0. Pretty much clear. And let's try to solve the example number 1 quickly. So now here is our question number 1. Find the triplets with sum equivalent to 0. So now over here, the first example, let me copy it and paste it. Okay, so the first example says array contains 0, -1, 2, -3, and 1. And the size of the array is equivalent to 5. This is what the first array contains. Now over here I have to find three triplets that have sum is equal to a plus b plus c will be equivalent to 0. This is what the question wants you to find. A, B and C. Find the value of A, B and C. I mean Just print 1 if A, B, and C are possible, else print 0. Okay, so let's see 0, -1, and -3. This will give you -4. It will not work. So let's say 0, -1, and +1. I've selected 0, -1, and 1. And I have found that the sum of this triplet is equivalent to 0. So I'll be having the output. If you are able to find at least one triplet that adds up to 0, then output needs to be printed as 1. Okay, that means yes, you have a triplet possible. And let's say if n is equal to 5, and over here a different test case. This is test case number 1, and the array elements are 1, 7, 9, 10, and 18. Okay, so what about this? Over here, will you be able to find any triplet that contains will that will add up to 0? No, because every element is positive element. So over here the output comes out to be 0. That no triplet is possible. Is the question clear to everyone? Already everyone read the problem statement. I hope every doubt of yours is clear right now. Okay, so now how to solve this question? Now I want the answer from the audience. Okay, so what can be the brute force approach? And are you guys like practicing the questions daily? How many of you like are practicing the questions daily? And along with that, write down the answer also. Like what can be the brute force approach? I'm just having a chit chat with you, all of you. 3 nested loop. Okay, yes, Pratik says 3 nested loop. Yes, and what will be the use of 3 nested loop? So the brute force approach can be finding out all the triplets, right? Just like the other question which we saw earlier, in that we were finding all the different pairs possible. So over here we can find out all the possible different triplets. And how to do that? For that we can have 3 different iterations possible. Okay, so basically let's say this is the array. Take some variable and keep it in the, okay, so T1. And now over here the brute force approach is to find all the triplets. Okay, so basically you can do something like this: -1, 2, -3, and 1. So now what you will be doing, the outer for loop will be iterating over this range, the inner for loop will be iterating over this range, and there will be one more for loop. This is the range of the inner for loop, and there is one more loop possible that will be iterating on each and every other elements. So that means it says that 0 and -1 are fixed. Now over here 2, -3, and 1 can be in the triplet. Okay, similarly you will be doing 1 and 2, and then you will be having possibility with -3 and 1. So this will be in a pair, and you can try out with this one. Okay, in that manner you can try out all the possible triplets, and for that you need 3 different for loops: I, j, and k. Right, I, j, and k. So overall what will be the, obviously the time complexity will be equivalent to n into n. In the worst case, each and every loop variable will be running over n number of elements. Space complexity order of, what will be the space complexity? Order of 1. Only nested loops are required, nothing else. So this will be the order of n cube approach. I want to do better than this. Okay, so n cube approach. So let's say over here, instead of okay, so this is one of the approach in which I am finding out all the triplets. So now can I do better than this? I don't want to do n cube. So let's say what can be the thing which I can do? So can I do anything about the outer for loop? No, at least we need to iterate over each and every element. What about the inner for loop that is from j? Can I do something about that? Can I do something about j and k? Can I do something about this two for loops? So basically, I already explained that if you want to find out any kind of sum in a sorted array, you can use two pointers approach. You can use two pointer approach if the array is in sorted manner. If the array is in sorted manner, you can use two pointers approach, right? So what I'll be doing, I will be replacing this j and k iteration with two pointers approach. Okay, so basically I will not be having three separate for loops, and I'll be simply using two pointers approach to find uh, two different elements with whom I can add the value at the ith index, and they will be having some equivalent to 0. Okay, so for this two pointer approach, I need the array to be in sorted manner. Okay, so now here comes our another approach that is far better than this approach. Okay, so now for this approach, I'll be using two nested for loop, and the inner for loop will be capable of it will be able it will basically the two pointer approach algorithm. Okay, so now for that I need the sorted array. So what I'll be doing, let's sort this entire array. That will be -3, -1, 0, 1 and 2, right? So this is the sorted array. Now basically one of the loop, that is the outer for loop, will be iterating over the other elements, that is from I is equal to 0th index till the last index. Okay, so now what I'll be doing, let's say I have picked one of the element that is at the ith index. Okay, Milan. So basically the first element is at -3. Now what I'll be doing, I will be looking for the elements in this much of part of the array. I'll be looking for the other two elements in this much part of the array. And if I add those two elements, let's say those two elements are b and c, I'll be getting some equivalent to 0. Now, isn't it similar to what we did over here? Over here also we were doing something like that, no? Comparison with key. So instead of key being something different, if key is equal to 0, I can use the entire approach over here. This entire approach along with one more variable can be used exactly in this part. Okay, so basically if I directly copy this part and add one more variable, that is array of I, at each and every line, this is going to work perfectly fine. Okay, so let me explain. Let's not directly just learn how to do this thing without knowing what is the actual reason. So now let's try to find the three elements. Okay, so now currently my I is standing at -3. So now I'll be doing, this is my left and right for the two pointers approach. Okay, so two elements are required. So now what I'll be doing, I will be adding -3, and I'll be adding the elements at L and R position. So -1 plus 2. So what will be the sum? -4 plus 2 is equivalent to -2. But I need the sum to be equivalent to 0. Now I got the sum to be -2, right? And what is the inequality between -2 and 0? -2 is lesser than 0 actually, right? It is lesser than 0. So now this element is the fixed. This is fixed element. I can do something about these two elements. Now -2 is lesser than 0. So that means this value needs to be increased. It is -2 and this is -2 and this is 0. I need to increase this value and move it towards this direction. So I'll be moving the pointer L, and now currently it is equivalent to 0. Now let's see what will be the sum. 0 plus, this will be -3 plus 0 plus 2, it is equivalent to -1. So now I'm a little bit closer to 0, right? So now I got the sum to be equivalent to -1, but it is still lesser than 0. So I again need to increase the value. So what I'll be doing, I'll be moving the pointer L. Moving the pointer L over here, and now your L and R are pointing to 1 and 2. What will be the sum? This will be -3 plus 1 plus 2 is equivalent to what? 2 plus 1, 3, and -3 will be equivalent to 0, and this is exactly equivalent to what my key sum was. So basically you got three triplets, right? -3, 1 and 2, right? Isn't it very much beautiful that how from how the two pointer approach was used earlier to find two elements, now it can be used to find three elements as well. Can your binary search do this thing? It can do, but basically you need a complex algorithm. You need to over there as well. You need to apply. What do you say? Sorting. Over here as well. You need to apply sorting. And also, if you will apply binary search, then the time complexity will be something like order of n into the time complexity to find which element what you will be finding. Over here, you binary search can be used to find a single element, right? And now let's say, till now, was it clear? Was the two pointer approach clear to you? So let's not discuss the binary search part right now. Let's focus on two pointer approach that is used over here. Is the two pointer approach clear to everyone which I have used right now? Just reply yes in the chat box quickly, everyone. Okay, thank you everyone for the confirmation. Now, what I'll be doing? Uh, let's try one more test case, or is it okay? I think this one test case is okay because we need no modification, no kind of no different modifications required compared to this. So basically, I'll be using this same algorithm by and I will not be writing a new algorithm again. And because one extra thing that we need to add is very much simpler thing, right? So what I'll be doing, I'll be using L and R. Now at each and every point, I will be adding array of I. Let's mark it with green instead. Array of I will be added to each and every, because the array of I is like it is fixed at this position. You cannot change the array of I. Okay, but you can change L and R. And over here you will be printing array of I as well in the output. So this is the entire approach. Now about this approach, you need a for loop. A for loop is required that will be iterating over all the elements that will be having loop variable as I, and I is lesser than n minus 2. What is n minus 2? Let me explain. Over, if you run the loop till lesser than n minus 2, then that means at the end two elements will be remaining, because this means this is n minus 1, this is n minus 2, and you are saying that your for loop will run from 0th index till lesser than n minus 2, till lesser than n minus 2 on this much of part. So n minus 2 and n minus 1 index will not be encountered by the loop variable I, because for the last element I need to apply two pointers approach over the last two elements. Okay, so I'll be running the loop in this manner, and this is the entire algorithm to find the triplets that add up to what? That add up to 0, right? How is the design? Okay. So now let's try to change this part into a coding implementation part. Okay. So now I'll be coding it in Java, but the same can be implemented with the help of the algorithm in any other different language as well, right? So now let's, first of all, the first step is to get the entire array sorted. Okay. So before this part as well, you need the array to be sorted. So what I'll be doing, I'll be calling the inbuilt function arrays.sort and array of I. Till then, can I know from the audience what will be the time complexity of this approach? The entire time complexity. Okay, so now I'll be using a for loop, and for loop will be from I is equal to 0 till I is lesser than n minus 2. We already saw why n minus 2, right? And now I need two different variables. L is equal to I plus 1th index, and R will be equivalent to last index n minus 1. So while L and R are not pointing to the same element, I will be doing what? If array of I plus array of L plus array of R. If this is equivalent to what? If this is equivalent to 0, then that means you have found a triplet. So return true from this part. Else what? Else if array of I plus array of L plus array of R, if this sum is greater than 0, as I mentioned, the element at the ith index is fixed element. If this sum is greater than 0, then that means I need to decrease the sum. So R needs to move in the rightwards direction. So R minus minus. Else, if this sum is lesser than 0, I need a larger value. So L needs to move in the rightwards direction. So L plus plus. Now let's say you have entire all the elements have been iterated. Now at the end, if you are not finding anything, then that means the answer does not exist. So at the end, I'll be adding return 0. That means no uh, answer is found in this test case. Okay, so let's try to compile and run. So what will be the time complexity? I already asked the question and no one replied. What will be the time complexity of this approach? Okay. N square. Okay. So basically it will be n log n plus n square, and the larger is n square, so overall time complexity comes out to be n square. Over here sorting has been used, so sorting takes n log n, and this is a loop that runs. Let me write down. This runs n number of times. This will be n log n, and this loop will run in worst case n number of times, and overall it is equivalent to n square plus log n. Yes, n square into log n. No, not n square into log n. Plus log n. Okay, Arushi. Okay, so now let's try to submit it. So now we can see that the problem has been successfully submitted. So Pratik says also at least one number needs to be negative. Yes, so we can break out of loop if array of I is positive. Array of I is positive. Okay, you can do something like that as well. When I is equal to 0, you will be, let's say if you will not be able to find the answer, then your L and R will cross their paths, and that means all the n elements will be iterated in the 0th index only if all the elements are going to be positive. So you can put a boolean variable that if L and R are negative, then only then you should proceed further. You can add if and else condition. That I'll be leaving on you guys. You guys are smart enough. You can add that condition. Okay, so now we'll be moving to the second question of this session, and the second question is count a number of substrings. So before moving to the second question, I would like to know from everyone, like any doubt till now, anything regarding any of the part of this question. Any doubt? Okay, so I see no doubts coming. So let's continue and let's see the second question. So the second question is count number of substrings. So basically, let me share the uh, link of this in the chat box. I've shared the link of this question in the chat box, and I will be leaving like on you guys to read down the problem statement, try to read the problem statement and understand with the help of test cases. Okay, so 2 to 3 minutes for this as well. Write down why in the chat box. That means yes in the chat box if you have gone through the problem statement. Okay, and then I'll be explaining the problem statement. Okay. Okay, Arushi already has read the problem statement. Okay, one more person, one more from the audience. Pratik, have you read it or not? Okay, yes, I got the confirmation. And what about Sahil? Okay, Sahil has left the session or what? Okay, so let's start. Okay, so count number of substrings. Okay, so the problem statement has a single, like it only has a single line. So that is, given a string of lowercase alphabets, count all the possible substrings, not necessarily distinct, that have exactly k distinct characters. Okay, exactly k distinct characters should be present in all of those substrings of the given string. Okay, exactly k distinct characters, not more than two or not more lesser than two. For this example, where string is equal to aba, you have to find out all the substrings, that is the count of those substrings which has exactly two distinct characters. So let's understand this part. So the second question of this evening is find substring, count the number of substrings. Count the number of substrings. Okay, so now I want to know from you guys, like it has already been the day 20 of this code camp, and like do you see changes in yourself? If you have been constantly practicing, are you able to observe some changes in yourself regarding learning DSA part? Have you been like consistently, some of you, I have seen some of you like have been consistently attending the live sessions, so are you able to see that you have upskilled your DSA skills a little bit? Because I know that it will be it is a constant, like you need to consistently keep on solving it, but I want to know what is your current situation, like how much will you rate yourself in terms of DSA in a scale of 10? Now 5, 6, or what is your rating according to yourself? Yes, consistency has improved at the very least. Okay, so if you will keep consistency, and if you will like go through like some, what do you say, good questions each and every day, not easy, like you should not. Let me tell you one more thing. So like you, if you are practicing, no, there is, this is three difficulty different levels, right? Different levels of difficulty: easy, medium, and hard. So don't get comfortable on any of the level too much. Okay, so if you can see that you are able to solve easy questions very easily, then directly jump to medium questions. Because if you will solve 100, or let's say 500 easy questions, and zero medium and zero hard, and let's say in other scenario you are solving, let's say 120 easy questions, or let's say 100 easy questions, and you are solving 400 medium questions, this will be far more effective than what you have solved over here. Or let's say not 400 as well, let me decrease the value to somewhat around 250. This will be far more effective than this count. Okay, so focus on coming out of your comfort zone, and don't get too much comfortable over here as well. You can keep on trying out hard questions. Okay, if you think like you are comfortable with medium, then I don't think this is going to take much amount of time to get very much comfortable with medium questions. So if you are able to observe the ratio of medium to hard, like the ratio of easy and medium questions, so medium questions should be more than hard questions. Okay, so that was the thing I would like to share with all of you. Okay, so count the number of strings, and I have copied the test case. Okay, so the test case is string s is equal to a, b, and a, and k is equal to 2. So now I have to find out all the substrings that has exactly two distinct characters. Okay, so let me first of all give you the idea about all the substrings. Okay, I'm writing down all the substrings: a b, a b a, b and b a and a. This is the count of substring. Okay, this is the substrings needs to be contiguous. It cannot have any kind of break. I cannot select a as a a is not a substring. Till now, was it clear? Any doubt till now? Yes or no? Okay, so I was saying that a and a cannot be called as a substring. So now I have to see how many substrings has only two distinct characters. How many distinct characters in this first? Zero. Over here, two. Over here, two. Over here, zero. I mean, one, not zero. How many over here? Two. And how many over here? Only one. So I can see this is our interest, and how many interest and how many strings output comes out to be three. Let's check what is the output given to us. The output given to us in the example one is also three, right? So now this means we have to find out substrings that has only two distinct or two, like let's say, unique characters. Let's see one more example. Input test case, a larger question. Okay, so input test case number, let's say according to this string over here, it is equivalent to ab a c a, and k is equivalent to 1. So all the substrings that has only one distinct character. Okay, so first of all, let's find out all the substrings. A, then that is ab, ab, twice ab, aac, and abaaca. The other one is going to be, it will be starting from b. What I can do, I can copy this much of part, and this is all the strings which will be start with a. Now the other that will be starting with a is this one. Now the other which will be starting with the other is this one. Now the other one which will be starting with C is this part, and the other one which is starting with the last one is this. Okay, so this is how you have all the substrings. This many substrings are possible. Overall, you can find n into n minus 1 divided by 2 number of substrings for a string with length n. Till now, is it clear? Any doubt till now? Yes or no in the chat box? I want proper engagement from everyone. Yes or no? Okay. So now, how many distinct characters? Just quickly finding. Okay, so how many distinct character? One, two, 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 three, three. One, 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 and one over here and one over here. So basically, this strings, right, are having one distinct characters. So let's see, there will be one more as well. So now, this all of them are having two or greater than two. This also has only one, and anything else it has two. It has got two. It has got two. It has got two. It has got two. So I can see one, two, three, and six and seven strings. Okay, so what is in the output for this one? The output for this test case comes out to be 7. I can see 7 strings having only one distinct character. 7 number of strings. You can observe the output also comes out to be 7. Okay, so now I hope the entire idea about the question is clear to everyone, that what actually the question is trying to say and what is a substring. Okay, the first thing that needs to be clear in your mind is that you need to know what is a substring. Okay, don't directly jump to the question and like, first of all, get the idea about substrings. So now let's focus on how to solve this question. Okay, so this question is going to be very interesting, And what do you think, what can be the approach, a brute force approach or anything from you? What can be the approach? Okay, so brute force says, Pratik says brute force can be in order of n cube. Yes, we can follow the brute force approach with order of n cube. Okay, so basically, let's understand how we can do with order of n cube. So basically, if you want to find out all the substrings, just like the triplet part, over here you can have three different for loops. The outer for loop will be running over the entire string. Okay. First of all, in order to find out all the substring, you need two different for loops, I and j. Now, whatever is the string in this range, starting from I to j, whatever is the number of whatever is the string in this range, for that string you need to find out how many distinct characters are there. Okay, and only increase the counter if you find that the string has k number of distinct characters. You will be keeping a counter variable and you can keep on increasing. So how many distinct characters are there? How can you find inside a string? You need to iterate over the string and kind of keep the track of uh, the number of characters, different characters which you have encountered. So let me give you an example. A B double A C A. So the first is the starting of the string and j denotes the ending of the string. So now the first string which I got, so j will be starting from ith index. Okay, because a substring can contain a single of alphabet as well. We can use hash table, hash set to count distinct characters. Yes, you can use hash set as well. So now over here, I to j, what is the string in the range? I to j, I can see a single character. Single character, how many distinct characters are there in it? One distinct character. Now what is the value of k given to us? K is also 1. This is also 1. Increase your counter. Now counter says 1. Moving on forward, j is over here. Now your string has increased and now string contains a and b. How many distinct characters? Now to know about distinct character, you can use a hash set. Inside hash set, earlier a was present, now b is present. How many distinct character? The size of this hash set denotes number of distinct characters, two distinct characters. But my target is to have only one distinct characters. One distinct character is only required. Now, if you will encounter any of the character, then do you think you will be able to decrease the size of this entire hash set? No. What I'm trying to say is that now if you keep on moving this j forward, is it possible that the size of this hash set will decrease? The size of this set will be decreased. Is it possible? Do you think? Not possible. Obviously, if you will encounter a new distinct character, the size will increase instead. But the size will not be lesser than 2 or it will not decrease by moving forward, right? So now, at this point, you can directly end the inner for loop. If this kind of condition is visible to you, you can end the for loop. Else, you can keep on continuation. You can move the value of j forward and forward, but the count variable will not increase and size might increase, but it will not be decreased. So now I hope this idea makes clear. Now after the iteration of j, you will move the I pointer forward and the j will now be deleted. So now the strings starting with the character b. So j will be pointing to I and all the characters from now. So your str I to j, string I to j is equivalent to, now what is your str I to j? So your str I to j is equivalent to b. Okay, and inside your set B will be present, nothing was there. Size is equivalent to what? 1. Now the next character, the J will be moving forward. So BA size will be now 2. So size was earlier 1. Okay, so let's say I was not encountered, J was over here only. Size equivalent to 1, it is equivalent to K. Increase your counter, counter will be 2. So now moving J forward, and now I can see A, B and A is present, right? Okay. So in this manner, you can use the three nested for loop in order to find the each and every strings with only K distinct characters. I hope this part is clear to everyone. Now this hash map can be hash set, or the set can be used and it will work in order of 1. So the time complexity if you use hash set comes out to be order of n square. Okay, if you are iterating and finding how many distinct is there, so this approach will be taking time complexity order of n square, and the space complexity will be equivalent to order of n in worst case. Because we are using a set data structure to store different characters. So this is the time and space complexity. Is it clear? Any doubt till now? And now after this part, I will be explaining a different kind of technique to you. That will be far better than this. Okay, so now let's quickly move down towards the efficient approach. So the approach will be, so now over here, the target was to use a hash set. In Java, you call it a hash set, or in other languages, you might be calling it a set or unsorted set. So now you can, instead of using a set, also you can use a map as well, right? So now here is the other approach, which will be using hash map, or you call unordered map in your C++. So now I will be using a hash map in order to find out the count of exactly k distinct characters. Okay, so now this approach is kind of trickier. You need to have the intuition for it. Like I'll explain hash map. So basically, it is very much difficult to find out exactly k distinct characters. Okay, so if you want to find out number of substrings with exactly k distinct characters, this is kind of not possible. So what I'll be doing, I have an approach to find at most k distinct characters. I have an approach, I'll be explaining that approach, that if the question was to find at most, find the number of substrings with at most k distinct characters. It means find the number of substrings with at most k distinct characters. That means inside all those substrings, there can be zero number of distinct characters, one distinct character, two distinct characters, but it cannot have more than k distinct characters. I have this kind of approach. So what I'll be doing, I want to find substrings with exactly k distinct characters. So I'll be finding out the count of substrings with at most k distinct characters. And along with this, if I have the count of substring with at most k distinct characters, okay, so let's say this is inside the count variable. Let's say this is the count variable, and I am showing you the inside of this count variable. Okay, if you observe inside this count variable contains the count of substring with at most k distinct character. If you observe inside this count, there will be count of the substrings with only one distinct characters. There will be count of the substring with only two distinct characters. There will be count of the substrings with only three distinct characters. There will be count of the substring with only four distinct character as well. This is C1, C2, C3, and C4. And if you add all of them, you'll be having the count of the substring with at most k distinct characters. Okay, inside the count of the substring with at most k distinct characters, you have C1 plus C2 plus C3 plus C4. Now let's say if I do Ck minus 1, what does it mean? Count of the substrings with at most k minus 1 number of, or let's say this variable L is equivalent to k minus 1. And what will be CL? CL, it means that count of the substrings with at most L distinct characters. You want to use the concept of backtracking. How can you use backtracking over here? Backtracking can be used whenever you are able to see that recursive approach can be used. If recursion can be done, then only then you can think about backtracking. Okay. Sorry. So what is CL? It is count of the substrings with at most one distinct character with exactly, okay, two distinct characters with exactly three distinct characters with exactly four distinct characters and with exactly L distinct characters. So L can be written as k minus 1. This says that ck minus 1, and this is plus ck. Okay, so C1, C2, C3, we know the meaning of C1, C2, C3, and this sum is something is it is over here as well. And inside this sum, if I add ck, it gives the count of substrings with at most k distinct characters. K distinct characters. This all sum plus ck will give you the count of substrings with at most k distinct characters. So I want to find actually the count of substrings with exactly k distinct characters. So I want the value of this variable. This is ck minus 1, entire ck minus 1, and let me call it as a, and let me call it as b. This entire sum as b, this entire sum as a. So if I do b minus a, and we know b is this much, that means if I remove this much of part from this b, I'll be getting the value of ck. So this is what I have to do. I have to find out the count of the substring with at most k distinct characters, and I have to find out the count of substring with at most k minus distinct characters, and from that I'll be getting the value of ck. Is this clear to everyone? Yes or no? Is this intuition clear to everyone? Reply from everyone yes in the chat box if this part is clear to you. Is it clear to only one person in the audience? Okay. So as I said, I already know the approach to find at most number of substrings with at most k distinct characters. So what is the approach? First of all, we need to understand this approach, and then only then we can directly use that approach inside our formula. Okay, so just a minute. Okay, so let's start the this part. Find the number of substrings with at most k distinct characters. Okay, so just a minute, give me. I'll be writing down a very huge example. Yes, the problem statement is exactly for it is for exactly k distinct characters. And Rohit Yadav says how to write array of 2I plus plus using array list in Java. So you can do it using, let's say, array dot get. See, first of all, you need to know about three different methods. First of all, you need to know how to change the value. Okay, how to change the value at a particular index in an array list, and then you need to know how to call or get the element at a particular index. Get method can be used. Okay, and plus plus needs to be changed to something else. Okay, so try to find out this many things. Okay, so I was saying that I note the approach, find the number of substrings with at most k distinct characters. So let me give you let me give you the idea about a string. P Q R S P Q Q R and T. Okay, so this is the entire string. I want to find out at most k distinct character strings, the count of k distinct character string. So now how will I do? So for that there is an approach. Let me explain that approach. So in this approach, what else I need? So I'll be using a hash map, or you can call it as an unordered map to store the character and its frequency. And along with that, I'll be having two different variables. One variable is called the num variable, or you can see, or you can call it as a answer variable that will give you the count, or I'll be seeing it as a count variable, and you'll be having one more variable that is called as index variable that will be giving the idea about the number of elements which you have included inside your hash map. Okay, and the condition for this hash map is that the size cannot exceed, it needs to be lesser than or equal to k, that the size should not exceed, let's say, 2. Okay, for this the size should not exceed 2. Whenever the size exceeds 2, what I'll be doing, I'll be removing the elements from this. Okay, I'll be removing the elements from the hash map. That means I'll be excluding the substring which I've included till now. So let's start. So I'll be having one variable idx. So idx will be with green color. That means index, it includes, it says that on the left hand side what is the string, at which index I have included the string. Okay, so this is the index 0 1 2 3 4 5 6 7 8 9 and 10. Now I have one more variable, that is I variable, that will be iterating over the entire string. So one by one, so currently my I is pointing to 0, and inside the hash map one is not, p is not present, so p with 1 has been included. So now moving I forward. So Q, you have to focus on the size. Size should not exceed 2. So what is the size right now? After including Q, after including Q, the size is equivalent to 2. Now moving the value of I forward, on whenever I move the value of I forward, I can see if R is included inside the map, the size will be exceeding K. It will be 3 greater than K, and K over here is equivalent to 2. To find out the substring with at most two distinct characters. So what I have to do, I'll start now. From now I'll be removing the characters which is pointed by idx. Idx is pointing to 0. So now this character needs will be removed. One of the occurrence will be removed. So that means its frequency will be reduced by 1. So now its frequency is 0. If any of the character in the map has frequency 0, then remove it from the map, because that indicates that is not the part of our. So one more important thing I need to mention, let me show you again. Okay, so again, I'm starting from the beginning again. So your idx is pointing to zeroth index, and your I is pointing to zeroth index. Okay, and the size of this hash map should not include, it should not exceed 2. So currently I is pointing to this, so p has been included inside your hash map, p with frequency 1. So now the distance between the left pointer and the id pointer, how many, whatever is the distance, that means the string, whatever is the string which you can form between L to I, that is the string which will be helpful to you. I mean, that is the string that has at most k distinct characters. It will be the part of that set, and that set is at most k distinct characters. So from left to I, whatever is the string you have included, total number of strings. So left to I, how many strings are included? If you want to find out, then that means over here, left to I will be always greater than the left. So I minus left plus 1 is the count of the total number of strings included inside this part. So left to I, how many included? 1 minus, I mean I minus I, this is I minus left plus 1 is equivalent to 1. So count will be increased by 1. So your count will be now equivalent to 1. So now again moving forward, including one more character. On including one more character, you can observe currently I have included a string with exactly one distinct character. Okay, and count was increased by 1. Now q, include q. Now size is equivalent to 2 for this set. Okay, so I can see I have found a string that is pq, that has two distinct characters. So this string can be in our count because we are counting for total number of substrings with at most k distinct characters. Okay, there is a difference between at most and exactly. So focus on my words, what I am trying to say. And if you have any doubt, just mention it. Okay, if you will miss any of the point, you will just be lost in the solution. So now include one more character, so move the value of I forward. So over here I have to include pq, right? So what is the string count? So that is I minus left plus 1. And what will be the sum? That is 1 minus 0 plus 1. Okay, so this is equivalent to what? It is equivalent to 2. So that means over here inside PQ, I'm talking about the entire string PQ and Q. So whatever is the character pointed by left, and whatever is the character by I, starting from 0, that many strings will be included. So over here now I am talking about the string P, and I am talking about the string PQ, and I am talking about the string Q. So 2 will be included. That is 1 plus 2 will give you 3. Till now I have found 3 as the total number of strings. Now even if I include R, your size will be equivalent to what? The size will be equivalent to 3, and R is having frequency 1. So size is equivalent to 3, it is greater than K. So that is not allowed. Size should be this. So now I have to remove the element pointed by IDX. So remove P from this. So P has been removed. So frequency reduced by 1. Now P is equal to 0. That means I'll not include any character. So delete this and move the value of I forward. So now what is the size? Until and unless your size is again lesser than or equal to k, you will keep on removing the elements pointed by idx. So now idx is pointing to 1. So now what is the size? Size is equal to 2. It is lesser than or equal to 2. So it is perfectly fine right now. So now you can again include one more character. So now what I'll be doing, I'll be including one more character. But before including the one more character, I need to increase the count because currently my this idx to I is pointing to a new string, that is q to r. Inside this there are two different strings, that is one string is r and the other string is equivalent to qr. So 2 will be included inside your count. So how will we find that value? That is found by I minus left plus 1. So what is I? I is equivalent to 2. 2 minus left plus 1. So 1 minus 1, that this is equivalent to 2. So 3 plus 2 will be equivalent to 5. Are you getting yes or no in the chat box? Write down yes in the chat box if you guys are able to understand this part, what we are doing. So whenever you are removing anything, whenever you are removing from this hash map, at that time you don't have to increase the count by I minus left plus 1. But whenever you are moving the pointer I forward, at each and every point you are seeing a new substring. So that means at that time your count should increase by I minus left plus 1. New character encountered, then include the count of substring inside your count. Yes, we are going to do this twice to find exactly k distinct character strings. Okay, so right now I am finding at most k distinct characters, and after this we'll be finding at most k minus 1 distinct characters. So both the counts, so subtract this count from this one, and you will be getting exactly k distinct characters answer. So now moving on forward, the value of I is moved forward. So now p is equal to 1 will be included. Your size is now equivalent to 3. It is greater than k, so this is not acceptable. So now what I'll be doing, I will be removing the character. So the idx points to q is equal to 0, so remove it from the hash map. And now again the size is 2. It's completely fine. So this will move forward, and it is now pointing to r. If this is now pointing to r, then what it means, a new string has been encountered, rp. So over here, this a single r was already included in the previous part. So now rp and p, so count will increase by 2. 3 minus 2 plus 1, 3 minus 2 plus 1, that is equivalent to 2. So 5 plus 2, 7. So we have found 7 strings till now with at most 2 distinct characters. So now again including the new character. So R is already present. So now the size will be equivalent to, it is still 2, but the frequency is now equivalent to 2. Size is also equivalent to 2. And now what else do we need to do? I need to increase, I need to include all these strings inside my count. So that is 4 minus 2 plus 1. 4 minus 2 is 2, 2 plus 1 is equivalent to 3. So in count will increase by 3. So this is equivalent to 10. If this is equivalent to 10, then that means earlier I included the strings RP and P. So now which strings I am including? If you want, if you pay attention, it is RP, R, PR, and R. Three different strings have been included. Okay. RPR, RP, and R. So again, following this process continuously until the size is greater than k. So now new string, new character S, size is now greater than k. So now I need to remove something. So remove this R. So one occurrence has been removed. So if the occurrence has been removed, what is the change in the size of this map? No change. So remove one more character. So now R was removed. So remove one more character P. Removing P. Now P has been removed from the map completely, and size will also be decreased. Size will also decrease, and now it is lesser than or equal to K. If the size is lesser than or equal to K, then it is completely fine. Now I am talking about this new string, that is P, PR, PRS. So the count needs to be increased by 3. That is 5 minus 3 plus 1. That is 2 plus 1 equals to 3. So count will be increased by 3. So 10 plus 3 will be equivalent to 13. Okay, so now moving forward, the ith pointer. So now ith pointer is P. So P is included in the map. So size is also increased, and size is now greater than K. So this is an issue. So remove the IDX element. So P will be removed. If P is removed, so this P was included. Now frequency is 2. So if P is removed, the frequency becomes 1. Do you see a change in the size? No. Again, remove one more element pointed by IDX. So R will be removed. Now your R is completely removed, so size will be reduced down to 2 again. And now we are again in the safe zone. Okay, now if we are again in the same zone, now we are looking at a new string. That is from which string? It is from, see, R was removed. If R was removed, your R should point forward, this IDX. So it is now SP. So that means S and SP is the new string. So P. So that means what is the difference? How many strings? 6 minus 5 plus 1 is equivalent to 2. 13 plus 2 is now 15. And now moving forward, including new. So this is Q. Now size increased by 1. 3 is greater than K. Now remove, start removing. So S will be removed. 0, size will be reduced by 1. So now S will be removed, and this S will move forward. Now we are looking at a new string, so include it. So that is 7 minus 6 plus 1 is equal to 2. 15 plus 2, 17. Right, 17. And then in this manner we can find the count of substrings with at most two distinct characters. Now similarly to according to this, we can also find count of substrings with k minus 1 distinct characters. Okay, so basically this part, b minus a, first of all you are finding b, that is count of substrings with at most k distinct characters, and then for a it is ck minus 1. Subtract them and you will be getting the value of substrings with exactly k distinct characters. Okay, so now let me write down this algorithm to find how many substrings have at most k distinct characters. So that algorithm goes like this. So what was the process? First of all, let me clear out the process. The process was, there was a count variable, there was idx variable. Idx was used to remove the characters from the string, and then there was a map to store character and its frequency mapping. This is 1, this is 2, and this is 3. And what was the other thing? I was supposed to increase the count. I was supposed to increase the count when? Increase the count when size of the map is lesser than or equal to k. At that time, increase the count. Increasing the count by what? So I'll say count will be increased by what? It will be increased by I minus idx plus 1. And the other part is, what I have to do? I have to remove the elements, remove the character at idx index, idx from the unordered map when the size of the map is what? It is greater than k. If the size of the map is greater than k, remove the element present at idx. Keep on removing the elements. Okay, and whenever the size of the map is lesser than or equal to k, then increase the count by I minus idx plus 1. Is this clear to everyone? Yes or no in the chat box? A quick response from everyone if this part is clear to you. This two part, when to increase the count and when to remove the characters pointed by idx. This is the like these two steps are the most important steps. Okay, so based on this, I'll be writing the algorithm as well. Okay, so based on this, let's write down the algorithm. So first of all, what else do we need? Just a minute. So now over here, According to the question, first of all, I need a count variable to store the count. What else I need? I need idx. It will be initially pointing to the first character, that is the index number zeroth character. And what else do we need? I need a map. That map will be capable of storing the character to its frequency mapping. It will be storing this many values, right? Now, after this, what was the process? The process was to encounter new and new characters each and every time. So, a for loop is required. I is equal to 0, 2. I is lesser than n. A for loop iteration is required. And whenever you encounter a new character, what you will be doing? You will be increasing its frequency. So, map of whatever is the character pointed by I, I'll be increasing its frequency by 1. So if you increase the frequency, you have to keep on checking the size of the hash map. So if the size of the hash map is greater than, let's say, k, so if the size of the map is greater than k, then what? Over here, we already saw, remove the character present at idx index from the map when the size of the map is greater than k. So when the size of the map is greater than k, I have to remove the character present at idx index. So basically inside the map, what is the character? Inside the map, the character is at the idx index. So s of idx is the character, s of idx is the character, and I have to remove this character. So I'll be, let's say, storing it inside a variable called as ch. And at the end, I'll be increasing value of idx. So this character needs to be removed. So map of ch, that means I'll be removing that character, so decreasing its frequency. Okay, and now it is possible that its frequency is reduced down to 0. So if its frequency is reduced down to 0, then remove that element from the map. Entire element needs to be removed, as we were doing over here as well, right? So remove the entire element from the map. Remove the entire character from the map. Okay, so this process will keep on taking place until your size of the map is lesser than or equal to k. Correct? And if the size of the map is lesser than or equal to k, then what I have to do? I have to increase the count when the size of the map is lesser than or equal to k. By what? I have to increase the count by I minus idx plus 1, because that gives you the count of substrings. Okay, it gives you the count of substrings in the range idx to ith element, ith index. Okay, and this is the end of the for loop, end of the for loop. And at the end, whatever is the value of your count variable, whatever is the value of your count variable will be printed or returned by this function. So this algorithm is going to help you to find count of substrings with at most k distinct characters. Okay, at most. But our question is to find the count of substrings with exactly k distinct characters. So now, with the help of this algorithm, I can find count of substring with k distinct characters, or I can also find the count of substrings with at most k minus 1. So I'll be getting the answer for both of them. I'll be writing this algorithm in a function in which I'll be passing the value of k as k for the first time, and for the second argument, when I call the function for the next time, I'll be passing the value of k as k minus 1. So I'll be getting both the values, and at the end, I'll be subtracting both the values, and I'll be getting the count of substrings with exactly k distinct characters. Is this part clear to everyone? Yes or no? Let me call this function as, let's say, function fun, in which I'll be passing the entire array. I'll be passing the entire string, and I will be passing the value of k. Okay, so basically your answer is what? Answer is the value returned by the function in which you are passing the entire string, and the first argument for the first call you are passing it as k kind, because you will be finding substrings with at most k distinct characters, and the second time you call it, you will be calling it to find the number of substring with at most k minus 1, and whatever is the answer for the entire test case. Is it clear? Yes or no in the chat box if this part is clear to everyone. Is this part clear to everyone? Yes or no? Crazy, crazy crick. Hi, hi, bye, hi. कैसे हो भाई? So basically, this is how I'm going to solve this question. So now, if I talk about the time complexity, okay. So earlier the time complexity was order of n square, right? Earlier the time complexity was order of n square. Over here, what was the time complexity over here? Order of n square. Now, what will be the time complexity over here according to the question, according to this algorithm? How many loops are there? I can see only a single loop. And this part is not going to take place. This is not going to take place, or the iteration is not going to take place each and every time. Whenever the size of the map is greater than k, so basically you will be inserting every character will be inserted once inside the map and will be removed once from the map. So two operations on every character of the string. Once it will be inserted inside the map, other is for removing it from the map. So it will be around 2n the time complexity, because two operations at each and every step. So overall time complexity can be considered as n, both for this call as well and for this call as well. So order of n plus n is the time complexity. What about the space complexity? I have used a hash map, so the space complexity will be order of n. Is this part clear to you? Order of n. Yes, yes, Milan. Yes, what? Okay, got it. So now I simply need to code this algorithm with the help of any coding language. I'll be writing this entire algorithm in a function. Okay, so I'll be first of all writing the function. So let's write down the function. I'll be calling it as function, and argument will be string str and in the value k, integer k. So now over here, what will be the thing I'll be doing inside this function? Let's write down from this. First of all, I need a count variable. Let's say I'll give the variable count will as long. Let's say I don't know. It can be as large as, what will be the size? It can be as large as 10 to the power 5. And substring will be 10 to the power 5 into 10 to the power 5 plus 1 divided by 2, 10 to the power 10 somewhat. So I'll be keeping it as long. Long count is equal to 0. What else I do need? What else do you need? I need idx index. I'll be having integer idx. Currently we'll be pointing to 0th index. Now iteration is required, right? For integer I is equal to 0 till I is lesser than n and I plus plus. Now in this iteration, what I need? And after these two variables, I also need a hash map. So in Java, I'll be creating a hash map. Map is equal to new hash. a new hash map has been created. So now, first of all, let's extract the character at the strth index, the ith index. This is the character at the ith index. Now, inside the map, I will put an entry of this character. So map dot put character ch, and there is a different implementation that I'll be writing at map dot get or default default. So if the element is present, which element? If the element ch is present, placement is for C developer. I have used Java. Should I give initial rounds for the company? Which kind of placement? Placement is for C developer, okay, and I have used Java. Okay, you haven't learned C language, is it so, Milan? So map.get or default, what will this function do if the entry of this character is not there inside your map? And it will return 0. If the entry of this ch character or the frequency of this character is there inside your map, it will return that value. So whatever is the value returned by this, I'll be adding 1 to it. So inside map, an entry will be made. Now I'll be checking what will be the size, map.size. If the size of this map is greater than k, I'm doing the same thing which I have done in the algorithm. You can observe. If the size of this map is greater than k, what else I need to do? I need to remove the element at idx index. I need to remove the element. So should I give the initial round for the company? Sumita Arora, 12. What are you writing? I am not able to understand. Okay, 12, what? 12th of July, you are having interview, huh? You are in 12th standard. Okay, okay. In 12th standard, you did C++. plus plus. See, if you have done C++, plus plus, if you are coding in Java, no? Okay, got it. If you are coding in Java, then obviously it's very much easy to code in C++ plus plus as well. Okay, so don't worry a lot about it. I think if you have not done C language at all, then you can watch a very 3 or 4 hours long video. Entire C language will be covered. Just directly practice it. Okay, at least you know a language, and Java is far more used in development part. Okay, so let me complete this part, and I'll be having a discussion with you. So if the size of the map is greater than k, so that means I need to remove the element at idx index. From where? From the map. Okay, from the map. So how do we remove an element? So first of all, removing an element, I'm not directly going to remove the element. I'm going to reduce its frequency. Okay, whatever is the frequency, you can observe. First of all, extract the character. So character is present at the ch. The character is called as ch. So after extracting, what I'll be doing, I'll be decreasing its index. I mean the I'll be decreasing its frequency. So first of all, inside the map, I'll be putting its new value, map dot put. Those of you who are from Java, you will be able to understand. For ch, I'll be putting a new value, that is map dot get or default map dot get or default for character ch. If the value is zero is equal to let's say inside the map, the value for it is already present. So that map get or default will return that value. After that value, I'll be subtracting 1 from it. And initial value, if the element is obviously present, element is already present. Map dot get what? Map dot get ch. And I'll be reducing its frequency by 1. And the idx will be now pointing to a new position. It will be increased, it the value of it will be increased by 1. So this is the part in which I'll be removing a character from the string. And what else I'll be doing after that? If I'm not removing, that means the size of the map is lesser than k. So this is the part. So one more thing needs to be done, that if the character has a frequency 0, then remove it from the map. And remove the entire thing from the map. You guys getting my point? This much of part, is this part clear to everyone? Or whether this is the same part? Okay, and the other part, let's code this other part, that is count increased by I minus idx plus 1. Count will be increased by I minus idx. Okay, thank you, Million. Idx plus 1. And observe over here, count will be increased by this, and this is present inside our for loop. And at the end, you simply need to return the value of your count variable. Count variable will be returned. Now it's very easy. From here, what I need to do, I need to call two functions. I need to call function str with the value k, and I need to call it with the value k minus 1. So this function fun is going to return the count of substrings with at most k distinct characters. Okay. So whatever is the value returned, I'll be calling it as, let's say, b, and let's say it is equivalent to a, and let's keep it as long. I have to simply return b minus a. Okay, or you can directly write down the functions itself. And let's try to compile and run. Okay, and let's compile and run. We got a compilation error, that is cannot find symbol str. Okay, so str, and this is a. Cannot find the variable n. Okay, so n is equal to, let's define the variable n is equal to str dot. So we are getting output as 2, but the expected is 3. So let's see what minor mistake did we make over here. 2 is equal to 2, 2 minus 1 is equivalent to 1. And let's see, this is your hash map to show the frequencies. Okay, so over here, instead of hash map, you can use array as well, frequency array, because we know that there are going to be only 26 distinct characters, right? And according to the alphabetical order. So instead of hash map, you can use an array of 26 size as well. Okay, so let me change that part. It will be better if I use an array, or let's say that we'll be calling it as map only. Okay, map is equal to new int, and let's say it is equivalent to 26. So this thing needs to be, it will be very much easy for you guys to understand. Okay, so let it be map for now because we need to know about the size as well. Okay, and if we are not using hash map and if we are using a map, we need to know about the size or size variable needs to be handled. For now, let's keep it map, and I'll be leaving it for you guys to exclude this map and include a frequency array instead of this. So now let's just quickly find out what mistake we did over here. Integer n is equal to length. I have removed the length. Count is this, and idx is equal to 0. And over here, I have, let's keep it over here. Okay, so every time I am not supposed to remove ch. I'm supposed to remove the character present at the index idx. Okay, not the character at okay. And if that character's frequency has been reduced down to 0, then remove it from the map, and idx will increase by 1. Okay, so this is what we were doing wrong, and we can see the output is perfectly fine. And let's try to submit and see the acceptance. Okay, over here we got as a time limit exceeded error. So the reason of getting time limited exceeded over here is that we are using many languages. So if I remove this hash map and let's say if I'm using a map over here, I mean an frequency array, it will be very much time efficient. So let's say 26. As Java is slower than C++, this might happen. Okay, and all of them are having. And let's say what is the size? Size is currently equivalent to 0 of this map. Now at the map, I will be going at the chth index, and I'll be increasing the value by 1. Before that, I need to check if inside the map ch was already present or not. If this is not equivalent to 0, then that means it is already. If it was not present, then that means I'm going to increase. So size will also increase of that map. And now over here, if I'm removing that character, then I will be decreasing the size of the map as well. And now if the size is greater than k, then you have to just follow this process. Let's try to compile and run. I'll explain this part what I did. So character ch is this, and map at this point, what? Okay, map dot get. Okay, so over here if I'm removing, then what I'll be doing, map of ch minus a, that index, and I'll be reducing its frequency by 1, and remove this part, map of ch minus a. If that is equivalent to 0, then reduce the size. So I have eliminated the entire map. I have used a frequency array. And now we can see it is working perfectly fine. Let's try to submit and see. And the problem was successfully submitted. So let me explain you what I did. Earlier I was using a hash map, okay, and hash map was using many different let's say methods, and that was taking much amount of time. Okay, internally hash map is kind of heavy also. So integer map, I have used a frequency map because I know that the size of the hash map is not going to exceed 26 because there are only going to be 26 alphabets. So I have used a size variable and I have used that what is this map. So now whenever I see a new character, I will increase the size variable. If the frequency of that character was equal to 0, then I'll be increasing its size variable. Okay, and I have increased the frequency of that character as well. So if the size increases k, then that means I have to remove the character at idx index. So I'll be finding which is the character at idx index, that will be ch. So I'll be decreasing its frequency, and if decreasing the frequency is now reduced down to 0, then that means it will be not the part of your map. So I'll be removing that character from the map. So size will be reduced and idx will be as it is. A small minor change, and now it will affect the expected space complexity because hash map has been reduced, has been eliminated, and now you're using an entire array of size 26. So size 26 is constant for every value of n, for every input test case. So till now, was it clear to everyone, yes or no, in the chat box, what exactly we were doing? Quickly, yes or no in the chat box if this part was clear to everyone. Okay, thank you for the confirmation. So now we have covered two different questions, and we have seen how the optimization can be done by using different let's say techniques, right? So any doubt till now? So I was seeing that someone directly wrote, right? So I saw Milan was having a doubt. So you were asking that you are giving the initial rounds of an interview, right? So after this, I'll be discussing the homework questions. So till then, we can have a discussion. Whatever doubts you have, I'll be more than happy to reply it. So Naman says, should I start Geeks for Geeks in the first year of college? First year of college, see, starting Geeks for Geeks is like not anything. Uh, it is not a course. Like it is not a subject. Geeks for Geeks is a platform. Okay, so basically, you have the uh, content which you will be getting on this platform is DSA centric. So you should get into DSA, and to study DSA, you can read down the articles, go through the courses if you are not able to stay consistent. Okay, so basically, you can start in first year, but it will be better like you can start in the let's say second semester. After the second semester ends, you can start at that time. But if you start early, it will be benefit for you as well. For internship preparation, yes, you can do. Okay, so now I see no doubts coming. So let's see the last question of this session that 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 I'll be giving you in homework. I'm sharing the link of it. So let's quickly read down the problem statement, and we'll be ending the session after it. So I want everyone to try this solution. So I've been telling you from last session that try the solution of this questions which are given to you in homework on your own. So basically, the name of the question is maximum rectangular area in a histogram. So this question is very interview, like let's say interview centric, and many times in interview, variations or many different variations of this question have been asked. Okay, so basically for this question, in order to solve this question, you need to study stacks. In stacks, you have studied about. Let me give you an idea. You know how to find out the next smaller and next larger element with the help of stacks, with the help of a stack data structure, right? So that technique is useful in order to solve this question. That was a hint from my end, and now let's see the entire problem statement. This was take home for stack problem in CodeCamp. Okay, so did you guys do this question? And those of you who were not able to solve this question, I would suggest go through this question. Solve it using monotonic stack. Yes, exactly. So you should go through the monotonic stack. You need to understand what actually a monotonic stack is. Okay, and there many data structures can be like they can store the data based on your ordering. Okay, so that is called monotonic, in increasing order, decreasing order. Thank you, Million. Like you're welcome if you really enjoyed this session. Okay. So I'm leaving the last question for you guys. Try to understand what the question is trying to say. As we already, it's 10 a.m. So I'll be ending the session here only. And if you have any doubts, I will be more than happy to discuss it with you right now. Okay. I'll be waiting for a few minutes and then I'll be ending this session. Okay, I see no doubts coming, so I think we can end the session here only. So, to try the last question on your own, and do not forget to share the submission in the comment section down below. Okay, so if you really enjoyed the session, then do like this video and share it with your friends if they are also looking for the same content. And if you're looking for such an amazing video, then do subscribe to this channel as well. Thank you, everyone. Thank you for joining, and it was great interacting with everyone. Okay, bye bye. Good night.